Hi everyone, I'm Krishna. Today I'll be presenting you all my research which focuses on extracting and understanding the role of quercetin from chamomile flowers and its effects on breast cancer cells. Now, let's start with why this is so important. Breast cancer is one of the most common cancers affecting women worldwide, posing serious challenges to treatment due to issues like drug resistance and side effects. This is where the nature lends a hand. Chamomile, a plant traditionally used for its calming effects, happens to be a treasure trove of bioactive compounds. One such compound, quercetin, is a flavonoid known for its strong antioxidant and anti-cancer properties. The aim of my study is to extract the quercetin from chamomile flowers, then quantify it and evaluate its effects on breast cancer cells to understand its therapeutic potential. For this, we started with the extraction process using the ethanolic extraction from the dry chamomile flowers. Then, once we had the extract, we employed the ultra performance liquid chromatography UPLC to quantify the quercetin content with the high precision. Then, using the commercially available quercetin, I conducted the MTT assays to study its cytotoxic effects on breast cancer cells. Then, following this, we analyzed the DNA fragmentation to assess its apoptosis inducing capabilities. Finally, I performed the antioxidant assay like FNC and DPPH on the chamomile extract to measure its phenolic content and also the free radical scavenging activity. And what did we find? So, our results were promising. The UPLC analysis confirmed the successful extraction of quercetin with the concentration of 68.52 microgram per mil. Um, Through the MTT assay, we observed that the quercetin reduced the viability of breast cancer cells in a dose and a time dependent manner, with the higher concentrations showing the significant effects. At 24 hours, the notable cytotoxicity was observed at both the lower, that is 10 micromolar, and the higher 300 micromolar concentrations, while the intermediate concentrations did not consistently produce the significant effects. But, however, in 48 and 72 hours, the cell viability decreases significantly across like nearly all the concentrations, which were more than 50 micromolar, which suggests that the cytotoxic action of quercetin becomes more pronounced with the extended exposure. And the most prominent reduction in the viability was recorded at 100 micromolar and 150 micromolar after the 72 hours of exposure. So, this suggests a cumulative effect of quercetin over the time, potentially due to its progressive intracellular accumulation or delayed activation of the cytotoxic pathways. Interestingly, 10 micromolar treatment, while effective at 24 and 48 hours, did not show a statistically significant effect at 72 hours. Then we come to the DNA fragmentation analysis, which revealed that the quercetin triggers the apoptosis, as it was evidenced by a clear smearing patterns indicating the DNA degradation. Then we had the antioxidant assays, which demonstrated the high phenolic content of 287.76 microgram GAE per gram of chamomile, and the substantial radical scavenging activity of 38.09 microgram GAE per gram of chamomile, which is further underscoring the extract's potential therapeutic impact. So, collectively, all these results suggest that quercetin not only exhibit the cancer cell proliferation but also induces the apoptosis. So moving forward in future research could explore the precise molecular pathways which like involves and optimize the formulations to enhance the quercetin stability and bioavailability for the clinical uses. um, yeah, that's mostly it, and thank you for your attention. I look forward to your thoughts and questions. Thank you.